Hey all, so this is Math 116, Section 6.2, Compound Interest. And we're going to look at a couple of different variations of compound interest in this section. First one's going to be future value with periodic compounding. And so we're going to pick up, we have all those same definitions from 6.1, and then we're picking up some new ones in here. So the old ones from 6.1 were future value is S, so that's how much money we're going to have in the future. P was principal or present value, so that's how much money we have today. R was the interest rate as a decimal. T was time in years. And so in this section, we're picking up I, M, and N, I think are the new ones. So up here I have N is going to be the number of compounding periods during the length of the loan. M in this formula is going to be the number of compounding periods per year. So say something is compounded quarterly. So that means it's compounded 4 times a year. So that would be M. And then let's say it's in the bank for 5 years. So that would be 5 times 4 would be 20. So the number of compounding periods would be 20 for that loan. Then we have the interest rate per compounding period. So that's the rate, the same one we were using for simple interest, but now that's also divided by the compounding periods. So again, if we think of if the interest rate was 10%, and there was 4 compounding periods, then the interest rate per compounding period would be 10% divided by 4, or 2.5% per compounding period. So we'll see those in these formulas. So this first formula actually, here it is with the I and the N in it. So if I wrote it with the R and the M, it looks like this. If I write it with using the N and the I, it looks like that. The reason they kind of make a new variable is you'll see these formulas get a bit more complicated later in the chapter, and then we're kind of actually thankful to have the I and the N because it kind of shorthands the formulas a bit. So, okay, let me do some examples with this. Okay, so question 1, find the future value if $2,000 is invested for 11 years at 9% compounded annually. Round your answer to the nearest cent. So our formula again for this is going to be S equals P 1 plus I to the N. And so let's go through and kind of identify what we can from the description. So find the future value. So what we're finding would be S. If 2,000 is invested, so that would be our P, that's how much we have today. For 11 years, that's going to be our time. At 9%, so, R is 0.09. And then compounded annually, what that means is there's 1 compounding period per year. And so that was the M. So for this one, so M equals 1. If I set up for I, then remember that I equals rate divided by compounding periods. So that could also be right here in the formula. Then the rate is 0.09 over 1. Because it's annually, it's just going to be 0.09. And then likewise, if I do the excuse me, find the N right here, that was MT, and so N would be 11 years times M, but it's just 1 again, so that stays 11. So as this M will, as we go forward, the M is going to be something other than 1, and then that stuff will matter. So for this one, though, it's pretty easy. So we just do S equals 2,000, and then 1 plus I, so that's 0.09 to the N, which is 11. And then we throw all that in the calculator, and if all goes well, it should come out S equals 5160.85, or at least that's what I got when I did it. So number 2 is what are the future value and the interest earned if $3,600 is invested for 5 years at 8% compounded quarterly? Round answers to nearest cent. Okay, so we're looking for future values. Remember that's S, so we don't know that one. And then the interest, and that's the capital I, like how much money. So those are the 2 things we're looking for. $3,600 is invested, so that's our present value for principal. For 5 years, there's our time, 8%, there's our rate, and then compounded quarterly. So compounded quarterly, that means M is 4 this time. And so that means once we know M is 4, then we know I is going to be 0.08 over 4, or 0.02, and N is going to be time times compounding periods. So 5 times 4, or 20. And again, our formula for this looks like S equals P 1 plus I raised to the N. So we're looking for S, and then P was $3,600. 1 plus I was 0.02. I could also have 0.08 over 4 right here if I use the other version of the formula. And likewise, 5 times 4, or 20 up here. And it's just a matter of if we're using the one where we already have the I and the N, or with the M present. And then throw all that into a calculator, and I get S to be $5,349.41. And then this one also asks for I. So for that, we just have to take our future value, subtract our principal, and then we'll get the difference on that would be how much interest was earned. So that would be I. Okay, number 3 is a little bit different. What lump sum do parents need to deposit in an account earning 15% compounded monthly so that it will grow to $100,000 for their son's college fund in 10 years? So in this case, we're trying to figure out how much money we have to put in there today so that we'll have $100,000 in 10 years. So remember, today's money is P for present value of principal, so that's what we're looking for. Account earns 15%, so there's our R. Compounded monthly, so that's our M. So they'll grow to 100,000. That's going to be S, that's our future value. And our time is going to be 10 years. So I think I'll set this one up using the other version of the formula, just to show it's the exact same thing. So if I had found down here, if I had found I would have gone R over M, which is just right here. And if I had found N, that would have been M times T right there. So you can use either version that you like. So from here, I threw all that in a calculator, and I got 1.0125 to the 120. And then I just divided all that over because it's multiplying the P. So just doing division. And same thing over here. And then just divided this in a calculator and got P to be 22,521.44. Okay, so number 4, what present value amounts to $15,000? So what present value, so we're looking for P, amounts to $15,000, so that would be our future value, S. If it's invested for 10 years, there's our time, 7%, there's our rate, and then compounded annually, so that's another one of those ones where M equals 1. So then that makes our formula S, so 15,000 equals P, which is what we're looking for, and then it's 1 plus rate over compounding periods, but the compounding period's 1, so it's just 1 plus the rate. And then it's to the compounding periods times time, which is still just 10. And then just divide all this out. So I added those together and got 1.07 raised to the 10th. And then just throw that in the calculator. And for that, I got P equals 7625.24. So we'd have to invest $7,625.24 now, so that'll be $15,000 in 10 years. Okay, so this next set of problems is still future value, but this time it's going to be continuous compounding instead of periodic compounding. So look for the word continuous in the directions rather than quarterly or monthly or some other sort of compounding period being indicated. Same stuff as the last equation, except now we have E, and E is that 2.718 number that we saw when we were doing natural logs. It's the base of the natural log, ln, from the last chapter. So number 5 goes, what is the compound interest if $480 is invested for 7 years at 5% compounded continuously? So kind of two things there. One is, what is the compound interest? So it's not asking for how much money would be in the account. It's asking for how much interest was made. So we got to do a little bit of work at the end. And then compounding continuously means we're using this formula involving E. So 480 is our, that is our P, that's our principal. T is 7 years, R is going to be 5%, or 0.05. And we just toss them in here, and what that gets us is S, which isn't quite what we're looking for, but it will get us there. So future value will be 480 e to the 0.05, and then t was 7. So we throw all that in a calculator, and that comes out to, let's see, it was S equals 681.15. But again, it asks for the interest, not how much money was in the account. So in this case, we're going to have to subtract the interest. So minus the, or sorry, we're going to subtract the principal, and then that difference is going to be the interest. So that will be 201.15. So that. Okay, number 6 goes, to help their son buy a car on his 16th birthday, a boy's parents invest $7,500 on his 10th birthday. That would have been super cool, huh? If the investment pays 9% compounded continuously, how much is available on his 16th birthday? So for this, we're finding the future value. So we're looking for S, because we're trying to find out how much money is in there on his 16th birthday. And principal is going to be the 7,500. 9%, that's our rate. And then how much is available on his 16th birthday, and they're starting this thing when he's 10, so then that means that that'll be 6 years later. And so then we just say S equals 7,500, E 0.09, and then times time. And throw all that in a calculator, and I got 12,870.05. Okay, so then the last thing in this section is annual percentage yield. And annual percentage yield, or APY, is basically a way to compare accounts that have different terms. So say one account pays 7% compounded monthly, and another account pays a little less, say 6.75%, but it's compounded continuously. Which account's going to pay more interest? And so what the APY does is basically boils everything down to simple interest so that you compare different accounts on the same scale. And our formulas for that, we have one again for periodic, one for continuous, and I think we've met all of the things that we're using in those last two formulas. So I'll just go straight to the problem. Okay, for number 7, find the annual percentage yield for an investment at the following rates. Round your answer to 2 decimal places. So first account's going to be 7.7% compounded monthly, and second one's 5% compounded continuously. So I'll be using both of these formulas. So just kind of referencing back to here. For this first one, our rate is 0.077, and our M would be 12 because it was monthly, and we're looking for the APY. So APY equals 1 plus R over M to the M minus 1. And so we have kind of all of our little bits, so we'll just toss those in. So 1 plus 0.077 over 12 to the 12, and then minus 1. And then I just threw all that in a calculator. And so then here's the calculator answer. And then it says round your answer to 2 decimal places. So you may think you have to be a little bit careful where the 2 decimal places are. Right now we're in decimal form, but we're finding annual percentage yield. And that's something that's going to be reported in terms of a percent. So this as a percentage is 7, so we're going to move 2 places, so 7.977 dash dash dash. So rounding to 2 decimal places is actually right there. So the computer answer for this would be 7.98%, but I think the percent sign's after the box. And then 5% compounded continuously. So for that one, it was APY equals E to the R, so 5% minus 1. And then again, just throwing that in a calculator. Calculator answer is this. And so we'll move the decimal 2 places, so that means we're rounding right there. So that'll be 5.1, and that would round up to 3%.